We have the model now basically showing us what a leveraged property investment, simple property investment, will perform at using DCF. This model only runs to 5 years, which is a little bit limited. Usually it'll run out to 10, maybe up to 20, and some cases longer times. We'll discuss the whole period later on. But an important practical element that comes into real estate investment is the matter of maintenance, capital expenditure, and perhaps even expansion of the property. You might buy a property investment, and somewhere along the way you might decide to renovate the kitchen or change the carpets or whatever, partly as an improvement, partly perhaps as maintenance. And so we need to be able to take account of the possibility that we are going to be doing this maintenance. In tax thinking, any expense, any cash which is spent on an investment, whatever, an expenditure that is going to have a life expectancy of less than 12 months is simply an expense. When it gets to being more than 12 months, you have to depreciate it and you have to consider its eventual replacement. In the property world, things like water heaters, curtains, carpets, kitchens, bathrooms, many things wear out. And over the period of time that a person may hold a property investment, that possibility of capital expenditure must be considered. As a result of that, we have added a line into our model for capital expenditure, and we will look at that now. We'll also consider the possibility next week of the depreciation cash flow, but I won't go into that now. But the two are related. Basically, if you have, let's say, a kitchen that has a life expectancy of 10 years, then every 10 years you're going to be putting in a new kitchen. That might be $20,000, $30,000. And in the periods while it's being used, let's say it lasts for 10 years, you're going to be depreciating it. Your tax and accounting studies will have covered that question. But for now, we just want to look at the capital expenditure, how to put that in so that at regular intervals, capital expenditure is included. Up here, well, first of all, we have the capital expenditure line. That's where we're going to put the cash flow effects. Up here, we have the relevant data. Now here, we've just put in nominal amounts, the likely capital expenditure. Now these are the things which are going to depreciate. So we're assuming that we're regularly replacing, let's say, carpets. And so they will be depreciated, but they also have to be replaced on a regular basis. Because we're only using a 5-year model, I'm going to actually artificially reduce the life expectancy of these things to 2 years to start off with. That's merely to make a point about the way these things work. What that means is that, let's imagine we've got something, let's say carpets, and we are renting it, and we're in a situation where we're not expecting our tenants to necessarily look after the carpets very well, and so we're anticipating changing them after every second tenant, and we're expecting a tenant every year. And so one way or another, we've got an economic life for our carpets of 2 years. Now you might say, well, carpets actually last longer than that, and this is where you have to make a prudent decision. But for this exercise, I'm simply using this artificially low number to help us do our calculation, show how it works. When you make your model for 10, 15, 20 years long, then and you're working the realistic data from industry or what have you, then you can put in more realistic numbers here. So this is purely for demonstration. Okay, so what we're assuming is that every 2 years we're going to spend $9,000. How does that work? Well, how do we get it to come in here? Well, we can say, yes, here in year 2, we're going to bring in a $9,000 expense, and we have $9,000 coming in the second year, and we can do something similar for year 4. And there we have a recurrent expense every 2 years, $9,000 coming in. Now that works, but it's rather ugly and it doesn't really relate to the variations that are possible in the data, especially when we go to a more realistic economic life. So what we want to do is have this cash flow, this replacement cash flow, replacing the carpets or the hot water system, whatever it's going to be, happening every now and then. Sometimes yes, sometimes no. Unlike the notional sale, which only happens once, we're going to actually have to want it to happen every time the year number is an even multiple of the economic life. That poses a little bit of a problem because it's not quite a simple if statement, not a conditional statement like saying, is the years owned equal to the year we're in? It has to do with multiples. Okay, what are we going to do here? We're going to form a conditional, and to do that, I'm going to illustrate by looking at a slightly less obvious mathematical fact, and that is that the even multiples are what happens when the year I'm in divided by the economic life is an even number. We can't actually illustrate it just here terribly well, unfortunately, because we're not showing decimal places. But, simply put, 3 is 1.5 times 2, so it's an odd number. What I can do, though, is I can compare the integer value of that division, the year number divided by the economic life, and see whether there's a bit of a decimal part to it. And I'll do that in an if statement. I'll just take this little piece of demonstration out for the moment. We'll come back here. What I want to do is build an if statement into all this. I'll just take out this equation completely to make it a little bit more transparent what's going on. We use the Excel if statement. I'm going to have a logical test now. Now the logical test is going to be to see whether the fraction or multiple you get when you divide the year you're in by the economic life. I'm going to F4 that, I'm going to absolute it. Okay, I want to see if that ratio is a whole number, and I'm going to do that by seeing if it's equal to the integer value, another Excel function, the int, the integer value, and it's going to be the integer value of the same thing. Close brackets, put a comma in, that's my logical test. Is F12 divided by D9 equal to F12 divided by E9 and just looking at the integer part? So if that's got a bit of decimal to it, a fraction added to it, it's not a whole number, then this will not be equal. But if it is equal, then I will come up here, take the value in F9, I will absolute that to keep it going to the same place as I copy that equation across, and if there's no decimal part, then we will bring in D8, and if there is a decimal part, in other words it's not a whole multiple, then I'll just put 0 in, and that will be my equation. It brings in the same number, 9,000. Now, as I fill this across, doesn't do anything here, but it does bring in the 9,000 across in year 4. That's nice because now I've got a equation here, it's a fairly complicated looking one, and even where the number returned is 0, the equation is still in there. Let's look at what happens as the economic life changes. I will look at 3 as the year, and you see it's coming in on the 3rd year. Put it in at 5. Okay, we're used to that from the other things we've been doing. If we put it in as 1, every year I place the whatever it is, the carpets or whatever, a bit unrealistic, but you see how this if statement now is only bringing in numbers when the year number is an even multiple of the year that I'm looking at. Okay, that's useful. It means that in order to have the sign conventions here, remember, if something is always negative, then we don't put the minus sign in the body of the DCF, but we just take account of it when we do our summations. Now, to do that, what it means is that when I do this sum down here, I have to do it in such a way that I'm always subtracting this number. Turns out that the before tax cash flow can be positive or negative, so I show signs for that when it's relevant. Likewise, the tax on cash flow, oddly enough, can be both positive and negative. The depreciation cash flow, we're going to talk about that next week, but it's always the same sign. This one is always negative, and so here we're not going to put the negative signs in, but we're going to take account of it in the equation. So you'll notice that here we've got E31 as the representation of how the capital expenditure comes in as a negative, and so that enables this to look a bit tidier, but these are still working correctly. That's all fine. And if we put this up to 5, just to test it, that's all working. Again, all working really nicely. And we've taken account of the capital expenditure possibility. If we extend our model out to 20 years, for instance, and just simply copy across all of our equations because the way we have them configured, that will all work nicely.